So for those who've been here before, we have a different theme for each prep hour. Today's theme is going to be quant. We're going to deal with 2 variable word problems, like a specific type of word problem that are often quite tricky for people. But a lot of the techniques that we talk about are going to be, I think, broadly useful for lots of different types of word problems, which are a big component of the test. So a big theme today is kind of effective process for word problems. Almost all of the problems we're going to do today are drawn from this book, which is an enormous, it's actually like 6 point something pounds now, compendium of all different types of problems, not just word problems, not just quant, it's verbal too. If you're going to get like 2 books, I'd say get the official guide that you should definitely have, and this book is a nice second book because it's enough practice problems you're not going to run out of stuff. Today we're going to start, because I'm assuming we have folks in kind of all different stages of prep. So we're going to start really simple, looking just at some key algebra mechanics, do a little bit of practice with algebra translations. And then we're going to start with a couple simple word problems, and we're going to work our way up to some very hard, very complex problems. So hopefully levels of difficulty to suit everyone at some point. If you're interested in the more advanced stuff, bear with us through the foundations. Reviewing foundations will help when we get to hard stuff. If we get to a point and it gets super hard and you feel overwhelmed because you're just starting out, don't worry about that. You know, you'll get sort of a preview of where you'll be, but certainly not expecting that everyone's going to be like amazing at solving every problem. That's why we're here. We're going to learn some stuff. So let's get into it. All right, so algebra foundations. I have 2 variables. I have 2 equations. There are going to be 2 different ways that I can solve for x and y. What's one way that I could solve for my variables here? What's one technique that I could use with something like this? Yeah. Yeah, oh, we've got both methods described perfectly. Awesome. Yep. So one method is going to be combination or stack and add. And the other is going to be to substitute. Always when I have 2 equations, 2 variables, my goal is to get one equation with one variable because that I know I can solve. So if I'm going to stack and add things, it's going to look like this. I'm going to line them up like this, and just add. X plus x is 2x, y minus y cancels out, 8 plus 2 is 10. Now I can solve for x. And then I could plug that value back in to one of my equations to find y. So really nice, stack and add them, my goal being to cancel out one of the variables. Substitution, very similar, same goal, trying to get one equation, one variable. What I'm going to do here is I'm going to solve one of my equations to isolate a variable. So I'm going to say, okay, what is x in terms of y? It's 8 minus y. Now I can take this and I can plug it in to my other equation, my x minus y equals 2. So instead of x, I'd put 8 minus y equals 2. I get 8 minus 2y equals 2. I'm going to move the 2y over, move the 2 over, so I get 6 equals 2y, and I get the same result, y equals 3. Just a different way of doing it. How do I decide which of these methods to use? Like for this particular sample problem, which of these methods do you like better and why? Jessica says stack and add. Yeah, nice. That's a really good point, Jessica. It's already set up in such a way that it's going to work really nicely. Yeah, Raj, Tara, yeah, everyone agrees. So as we get into more complicated problems, when we get to the moment in a problem where we're going to just like do the straightforward algebra part of it, it's always a nice idea to look at how are my equations set up, which of these 2 methods is faster. Because you can do these problems either way. but making really efficient choices about mechanics is a great way to just take, 10, 15 seconds off of each of these problems you're doing. And that's going to add up over the course of a section. So one component of the word problems we're going to do tonight is just going to be going through the algebra mechanics quickly and accurately. The other big component that we're going to practice before we start doing some full problems is going to be taking sentences and phrases and translating them from words into algebra. So we're going to do a little bit of practice with that. All right. So take a moment. X is 4 less than Y. When you're ready, chat this as an equation. If I translate this sentence into an equation, what would it be? Cool. Craig and Namdi have some answers. Do you guys agree? Yeah. Ooh, Tara, we have the reverse. So a good thing to do to double check your translation is always to ask which is bigger. Like which of these is bigger, X or Y? Yeah, nice. Tara, is that reflected in your equation? If you plugged something in for X, would you get a bigger value for Y? Yeah, exactly. Yep. So if you notice that you just tend to flip these things around, add that double check in for yourself. Which is bigger? All right, let's try the next one. Aya is 6 years older than Shiv. Take a moment when you're ready. Chat in. How would you translate this? Cool. We have responses from Nikki, from Jessica. Do you guys agree? Bavaria. Nice. Yep, everyone agrees. A equals S plus 6. And that makes sense because Aya should be older, and that's reflected in our equation. All right, let's do a tricky one. There are half as many apples as bananas. And this is a good one. If you feel this one is shaky, play the same test with it. Which is bigger? Is that going to show up in the equation? Yeah, we have fewer apples. So we're going to say the apples is equivalent to half of the bananas. Nice. All right. I have at least 5 chickens. What are we going to do with that at least? Ooh, yeah, yep. So at least at most, instead of having an equal relationship, now we're going to have greater than or equal to 5. Sum of W and Z is greater than 100. Got responses from Jessica, from Craig. Rest of you guys agree? Tara. Yeah. Greater than, just our straightforward greater than sign, sum of W plus C, greater than 100. And one last one. Aya, sorry, we're back to Aya. Aya is at most twice Shiv's age. Yeah, so if at least is like this, at most is going to be the opposite. Aya is at most twice, 2 times Shiv. Cool. So another thing that I think we're starting to see here that's going to help, especially when we get into the really tricky stuff in word problems, is you can translate things almost word by word, phrase by phrase, taking them one little piece at a time, translating into math notation. So something that you can also do if you find these types of translation problems tricky is you could even make a little dictionary for yourself, like on flashcards. Say like, okay, if I see at least, how do I want to translate that? And then put greater than or equal to on the back, or make a list of sort of common translations so that you get super fast with this. All right, now we're going to put these two pieces, algebra mechanics with two variables, translating English into algebra. We're going to put them together, starting with a simple problem, working our way up to some very hard problems, step by step. So here is our first problem. I'm going to give you guys maybe somewhere between 1.5 minutes and 2 minutes to work on this. When you are ready, actually, don't chat your answer until I ask you so you don't influence other folks. Here you go. All right, when you are ready, go ahead and chat in your answer. Yeah, awesome. I like what I am seeing. Overwhelming support for V. You guys are great. Easy. I'm going to just take a moment on this problem to walk you through my process for 2 variable word problems, because this one's easy, we're getting it, it's good, so we can use it to illustrate process. And then I think having a strong process for this type of question is going to allow us to start scaling up, because the next problem we're going to see is trickier. They're just going to keep getting trickier from here. So I rush. So for me, I like to read things 2 times. On my first read, I miss details, I make small errors. That's the bane of my whole existence. I've dropped my wallet like 4 times in the last week. It's total character flaw. So I rush, I'm just gonna focus on the question. And I'm gonna say, okay, what's the question? I'm looking for pairs. And I'm gonna write down on my paper pairs. Because you can bet if a problem has apples and pears, there's gonna be a trap answer that's the number of apples. So I'm gonna set a target. And that's step 1, ID question. write down target. Because a lot of times there's going to be a twist or an error to make there. Next, I'm going to go back to the start of the problem, and I'm going to unpack. I'm going to stop kind of at each piece of punctuation and unpack what it's saying and start my translation. So, okay, she bought apples and pears. Cool. I can immediately assign variables. And I'm going to be really clear about that. And this step is going to be really important when things get more complicated. I'm going to say A equals apples, P equals pears. Obvious for this problem, but it's going to help us later on. Then I'm going to translate that first sentence. She bought a total of 12 apples and 12 pears. Cool. My first equation, A plus P equals 12. That's my next step. Translate one piece at a time. And I'm going to get my two equations set up separately, and then I'm going to combine them. I'm not going to try to combine as I go, because that, again, is going to really trip me up as things get complicated. So for my second equation, if she bought 2 more apples than pears, 2 more apples than pears. Okay, so my second equation, she has more apples. That's going to be apples equals P plus 2. My next step is just to sort of simplify each equation as much as I can, and then decide how to combine. Do I want to substitute, or do I want to stack and add? Which one should I do here, substitute or stack and add? Yeah, that's how it's set up, right? I have A isolated here, and I'm looking for P, so it's really easy to just take P, plug it into my first equation. I get 2P plus 2 equals 12, 2P equals 10, P equals 5. Awesome. So far so good, simple, straightforward. Important thing here is process. We're going to keep applying this same process. It's going to help us scale up and up and up to harder and harder stuff. So now we're going to try another one. This next one is going to have a new wrinkle, a new twist in it that makes it a bit trickier. Really, really, I challenge all of you, be rigorous about your process here. Step by step, one thing at a time, making good decisions all the way throughout. I'll give you a similar amount of time to work on it, maybe a little bit longer because it's a little bit trickier. Here you go. All right, go ahead and chat your answer if you have it. You can also chat, I'm almost there if you're still working, or I'm stuck if you got stuck somewhere along the way. Cool. Keep going. You can chat your answer when you have it. What about other folks? I'm not seeing the same rush to answer as the last one. Okay, cool. Take a little. Yay! I'm glad you're here, Craig, because this is the whole theme of today. We're just gonna do more of this. Um, and I'm hoping that I can get you to a place of feeling like you have a system for them, or starting to develop a system for them, because that's gonna help. Give people like 15 more seconds to keep working. Also happy to hear from other folks. Are other people stuck working? Where are you at? Cool. Yeah, this one got a lot harder. What's the hard thing here? It's not that different from what we saw before. But let's pause. Let's do this one together. Yeah. So let's do this one together, and then Mohsen, you got to the right place. I like it. We are going to eventually get to D. That's our goal. So if you get to D or got to D, awesome. It's the in 2 years. It's really hard. We're not going to deal with it yet, though. We're going to go through our process, and we'll deal within 2 years when we get to it. So ID the question. How old will Chen be in 5 years? I'm definitely going to write down like C plus 5 on my paper, because I'm going to be really tempted to solve for Chen and then just input Chen's age and not Chen in 5 years. So I have my target. Now I'm going to assign variables. And this is where this step gets really helpful. I'm going to say B is Bryony now. And C is Chen now. And it's really important that I'm very clear that B and C are their ages now, because we know we have this time shift, and we're going to want to be super clear about that. All right, now let's go back to the beginning. Let's just start translating one piece at a time. Bryony is 7 years older than Chen. How does that, let's translate just that sentence into an equation. When you got it, chat it. Cool. Yeah, we got this. We know what to do. B equals C plus 7. We're essentially just going to keep doing that. There's just going to be a couple little twists. I couldn't decide if I wanted to say twist or trick, and was like Twix. Very special. So now let's get into our second sentence. And this is the hard part, and this is the big moment. I'm just going to deal with in 2 years by itself. Then I'll get into the rest of the equation, the rest of the sentence. But I'm just going to deal with that one little piece, that one little hard piece. What I don't want to do is assign 2 new variables. Like, I don't want to say like X is Bryony in 2 years and Y is Chen in 2 years. Because if I start throwing around 4 variables, like 4 variables is going to be a mess. I'm going to be here forever. So I'm going to keep my same 2 variables. B is Bryony now, C is Chen now. And I'm just going to modify those variables. I'm going to turn them into little expressions for my new situation. So if B is Bryony now, what's an expression that represents Bryony's age in 2 years? Terry says, Craig, B plus 2, B plus 2. Yeah. So Bryony in 2 years is B plus 2. And what's Chen in 2 years? Yeah. This is the other important part of these age shift problems. you have to apply it to both. That's, Craig, that's the trap you're falling into. Because now when I translate the rest of the sentence, yeah, Taylor, that can work. My personal preference is to not try to combine the two equations yet. I want to kind of deal with the both situations separately and then combine. For most folks, that's going to make this like simpler and more replicable as we get into harder problems. If it's working for you though, don't let me stop you. But my preference for these to make them just cleaner and more straightforward to process is to do sort of the two situations distinctly. Yeah, so now I can deal with a Bryony will be twice as old as Chen. So I'm going to say, okay, Bryony in 2 years will be, that's my equal sign, twice as old as Chen will be in 2 years. And it's really important that I put the brackets here because that's Chen's whole age in 2 years. So I want to make sure I'm multiplying the whole C plus 2 by 2. And now you can see very literally I've like taken the sentence from English into algebra, but I'm just doing it one tiny piece at a time. Before I go further, does anyone have questions about that? That was like the big difficult mountain to climb in a problem like this. And now it's going to be downhill. So let's pause and see. Folks who are feeling stuck. Tara, Megan, other folks. Cool. We're getting better. All right, we're going to have a bunch more chances to practice with this too. So the next thing I'm going to do, third step, simplify both equations. This one's simplified. Let me clean up this one. Cool. Now I can decide what method should I use to combine my two equations. That makes sense here. Yeah. Now I can substitute because I know what B is equivalent to in both. So now I can kind of combine, set them equal. Say 2C plus 2 equals C plus 7. C equals 5. Is my answer B? No, that's the other term. Yes, no. That's why I wrote down C plus 5. So I've solved for C, but I'm looking for C plus 5, her age in 5 years. My answer is D. Did anyone do this differently? Did anyone do this without using algebra? What would be another way that we could do this problem if we really hated the algebra? Yeah, we can plug in answers. So if you're stuck, possibly, any answers that we could eliminate quickly though and not have to test? Yeah, because like if she's 2 in 5 years, she'd be -3. So I could get rid of that. If she's 5 in 5 years, she'd be 0 now. And that also seems kind of weird. Like I would also probably like downvote B. And so if I was going to test here, I'd start with C or D. If we have time, we'll look more deeply at back solving. I think there is also another free prep hour on our YouTube channel that's just about back solving. So you can also maybe go check that out. Today, my big focus is like, let's do the algebra. But I do want to make it clear that like we don't always have to do algebra. And if you don't like algebra in situations like this where you have numbers in the answers, you can test them. And there are ways to work through the testing so that you're never testing 3 or 4. You can usually get there with only testing 2. Again, if we have time, we'll look at that, but there's some other resources out there for that strategy as well. All right, we're going to try another one. Any questions before we do? Before we try this next problem, I want you all, just for yourselves, make a note to yourself, what are you going to do differently next time? Like, what's going to help this next one feel smoother, feel faster? It's going to be a very similar type of problem. So think about something to change in your next problem. All right, this one's going to be very similar. Here you go. Good luck. All right, go ahead and share your answer. Where are you at? I'm already seeing a lot more answers this time. I feel like this is going better. Yeah, this is looking good. I like it. Why did this one go better? What did you guys do differently this time that made this one go collectively so much better? Because you guys are all arriving at the right answer. What's making the difference here for you? Share with us. Oh, nice. Yeah, assigning variables really clearly. Yep, adding the year shift to both sides. Yeah, keeping the two timelines straight, reading the question twice. Yeah, yep. Me too, Nikki. That's my big challenge is like sloppy work. So I do it twice. I'm even when I see something and I'm like, oh, I know how to do this. This is gonna be great. I still come back to the same process because I know if I think it's easy, I want to get those points. I don't want to make a small mistake. Folks have questions with this? Do you want to see me walk through the solution to this, or are people feeling ready to move on and try something trickier? Yeah, I'm gonna do a quick walkthrough. Then we're gonna see a harder one where there's a different type of twist. Cool. So same thing. I'm looking for M. M is Michael now. N is N now. And I'm gonna do one sentence at a time. Norman is 12 years older than Michael. Cool. Norman is Michael plus 12. Cool. Then I'm going to get into the shift in 6 years. So in 6 years, if I'm starting with n, I'm going to have n plus 6. And then I'm going to have m plus 6 as well. He will be, Norman, so this is Norman's age, will be equals twice as old as Michael. M plus 6 equals 2m plus 12. I'm going to just isolate n equals 2m plus 6. Now I can go ahead and combine my two equations because they're both equal to n. 2m plus 6 equals m plus 12. M equals 6. And that's what I was looking for, m. So that's my answer. So just one step at a time. I was just working with a student earlier today, and something that we were talking about that might be helpful to keep in mind, particularly as we're going to get into harder stuff. Even the hardest questions can be broken down into sort of a series of simpler questions. Like there's no one step here that's insane. There's just a lot of steps. And so if you think of this not as a sort of complicated question, but as just lots of tiny questions packed together, maybe that helps. Maybe that doesn't help you, and then let it go. But that's my big thought for the day about GRE problem solving. All right, lingering questions on this one, because now we're going to look at something trickier. All right, we're going to look at a new twist. Okay, I'm going to give you guys some time to look at a new twist. Same process, same kind of thing. It's just going to look a little different. All right. If you have an answer, share it. If you're still working, let me know. If you're stuck, let me know. Cool. What's different here? How is this different from the age problems? In many ways, it's similar, right? We have two sentences, we have two variables, we're going to have two equations in the end. It's more complicated. Yeah. Yep. Instead of having everyone shifting in the same way, we're going to shift in a different way because we have an exchange. And that's going to make it harder. But same process. So what's the first step? What's the first thing I want to do? Yeah, what am I looking for? What are my variables? I don't want to do this in yellow. That's going to be painful. I'm going to do, okay, A equals Anka now. And that's what I'm looking for. That's my question. C equals Conrad now. Cool. First equation. Anka has 5 fewer candies than Conrad. What's that as an equation? Yeah, nice. 2 different versions of the same thing. A equals C minus 5, or A plus 5 equals C, whichever setup you prefer. There's advantages. They both work. Cool. So first equation, so far so good. Now I'm just going to think about the exchange. I'm not going to deal with the whole sentence. I'm just going to think about this exchange. So if Anka starts with A and she gives Conrad 5, how many candies does Anka have in terms of A after the exchange? Cool. Yeah, Anka is going to have A minus 5. And how many candies is Conrad going to have? Nice, Nikki. That's the twist. So it's just like our age problems where we want to apply the age shift to each person. But instead of having plus on both sides, one person's going to lose, one person's going to gain. There's going to be a push and pull. So now I can take these 2 expressions and put them into this equation. Conrad will have, okay, so Conrad will then have, I know that Conrad will then have his C plus 5, and that's equal to 4 times the candies that Anka will have, which is A minus 5. I was going to say, everyone give me a thumbs up if you're good, because I'm used to teaching when everyone's on camera, but we have too many people for that. So everyone be like, yes, we're good, or no, we're not good. Very good. Yes. Yay. Awesome. Yep. Now we just clean up the algebra, get them both real simple. C equals 4A minus 25. And this is where I think it was Tara, Nikki, arranging this equation as C equals A plus 5 is super nice, because then when I combine, I just set them equal. Notice that the algebra mechanics in these problems actually aren't super bad in the end. It's the processing and the setup that gets really bad. So I get 3A equals 30, A equals 10. All right. So far, so good. We're going to get harder. That's the theme of today. Depending on how it goes, this may be our hardest problem. Maybe I'll throw an even harder one at you. I don't know how evil I feel yet. We're going to do a harder one. It's an exchange problem like this one. So keep in mind the lesson from how we applied the exchange here. The next one is also text entry. So you won't have answer choices to help you. That's also what makes it harder. Good luck. I'll see you in a couple of minutes. All right, it gets harder. Who has an answer? And if you don't have an answer, what's tripping you up? Oh, nice. All right. We're getting there. Cool. Where are people getting tripped up? Because it's going to be a very similar pattern, very similar process. Listen, you're super close. So the answer is 36. Maybe it's a small error. Yeah, Tara, I think there also might be a small error in there. So let's walk through it for everyone. I'm looking for Bryn. And I'm going to say like B equals Bryn now. Yeah, yep. I think, Terry, you got it. R equals Ravi now. First equation, Bryn has 16 more than Ravi. That's our sort of, there's always kind of like an easy equation and a hard equation. So I have B equals R plus 16. I'm just going to deal with the exchange. So what happens after the exchange? If I start with B and R, what do I have in my new situation? After she gives Ravi 6, what does Bryn have? Nice. Yeah, yep. You got it. So yeah. Tara's going all the way there. Yep. I'm going to do B minus 6, R plus 6. And now I can translate the rest of this sentence just word by word. Okay, she will then have. What's that? That's the B minus 6. That's what Bryn is going to have. 22 less than. So there's going to be a minus 22 in here. 22 less than what? 22 less than twice. So there's going to be a twice something. Twice what? Twice the number of tickets that Ravi will have. So that's my R plus 6, again with the parentheses. Okay, so what Bryn will have is equivalent to 22 less than twice the tickets Ravi will have. I can really just go like word by word, phrase by phrase. So if trying to sort of process that whole sentence as a unit is like, that's so much information, it's cool. You don't have to do it. You can really just bit by bit kind of pull out things, translate, arrange them, go back to the sentence, double check, but you really take your time with that translation because once you get the translation down, the hard part is done. So that's my second equation. Now I'm just going to simplify it. B minus 6 equals 2R plus 12 minus 22. And I actually will write out a lot of the steps like this because I know it's really easy to make a small error at this point. Add 6 to both sides. B equals 2R minus 4. Now I have two simple equations, so I can set them equal to each other. And now this is why I write down Bryn's tickets at the top like this. Because I've done all this work. I'm really excited. I'm like, yes, I did it. And it's really easy, especially because this is text entry, to like type in Ravi, and then you lose all this amazing, clever, beautiful work that you've done to solve this really hard problem. So I've written down Bryn. I double check. Is that what I've solved for? Nope. If R equals 20, then Bryn equals 36. And that's my answer. Yeah. Yep. Other folks, what was the part of this problem that tripped you up? This is our super hard problem for today. And are there pieces you still have questions on? Yeah. Nikki, I'm also prone to this. So I use a lot of like brackets, parentheses, things like that. to keep it really straight. And I try to just do the algebra, like what I've written on the paper here is probably what I would write on my scratch paper on test day. Like I try, yeah, yep, brackets, parentheses. I try to write down like all the steps in my work too, because that way if I do make a small error, I'm going to be able to spot it. And it's going to help me from making small error. Yep. That's another classic mistake, solving for Robbie instead of Bryn. All right. So, final thing we're going to do. That was a hard problem. We're done. Really good thing to always do when you study at the end of a session, sit down, write down, recap for yourself. What are the like 1 or 2 big things you've learned that you really want to remember? So, everyone in the chat, share what's one thing you learned today you want to remember. Nice. Have a systematic approach, word problems. Break down the question. One piece at a time. Time shift exchange goes both ways. Watch variables. Ooh, don't do it in your head. Write down the small steps. Yeah, the less you try to hold in your head, the less tired you'll be. Like I always think like I'm going to outsource all my work to the paper and then I don't have to think as much. And then by problem 40, I'm going to be way more efficient and in a much better mood. Yeah, read carefully more than once if you need to. I love these. These are great. I think my big takeaway that I would add to this is something that hopefully goes beyond just these word problems and maybe something that you started to see today. The same process that works for an easy problem is also going to work for a really hard version of that problem. So if as you study, you're really rigorous with yourself about having a really methodical, consistent approach on an easy problem, that's good. Even if you don't need that system for that easy problem. Because if you can do it with the easy problem, it's going to help you scale up to the hard problems faster. So always have a clear process, be consistent, be rigorous. That's going to help you break down medium and hard and extremely hard problems. We've done some easy problems today. We did a super hard problem today, but we use the same consistent process throughout. Yay. Thank you guys all for being here. Thank you for being so engaged. If you want more free stuff, there's a lot more free stuff online. Thank you, Nikki. That's so nice. You can take the first session of any of our courses for free. So that will be like a big, broad introduction to quant, to verbal, lots more process problem solving stuff. These free prep hours are recorded and put on YouTube, so you can go scroll back through there, find tons of stuff on different topics. And I wish you guys all lots of luck. I hope you get to the score you want as soon as possible and can move on to more exciting things in life. Have a wonderful night. Enjoy the rest of your week. And hopefully maybe I'll see some of you back here in a future free prep hour.